Compressed air engines are making a comeback, poised to revolutionize the automotive world with a game-changing zero-emission technology. Picture this: a new engine design that could outshine both traditional internal combustion engines and electric vehicles in terms of fuel economy and eco-friendliness. Despite their modern reappearance, compressed air engines aren't entirely new. They trace their roots back to the 19th century during the Second Industrial Revolution. The Marari system, an early pioneer, used a single piston to expand compressed air, which was then reheated in a hot water tank before entering the engine. This ingenious setup improved vehicle range and saw use in trams and mine locomotives. However, with the rise of fossil fuels, this technology fell by the wayside. Fast forward to the 21st century, and renewed interest in this technology has emerged. In the early 2010s, companies like Joe reignited the compressed air engine's potential by developing hybrid vehicles like the Joe 208. These prototypes combined internal combustion engines with compressed air technology, achieving an impressive 141 miles per gallon. The vehicle could switch between air power for acceleration and gasoline for cruising, offering versatility and efficiency. The Joe 208 featured a dual powertrain system, a gasoline engine and a compressed air system. The latter included a tank below the boot, a low-pressure chamber near the rear axle, and a hydraulic system in the engine bay. This setup allowed for quick recharging of compressed air, whether through braking or using the engine. Although these vehicles were experimental, they showcased the potential of compressed air engines and drew attention from other manufacturers like GM. Today's compressed air engines have evolved significantly. Unlike the Marari system's single-stage design, modern engines are piston-driven and operate at much higher RPMs. Springs now handle piston movement, and traditional water heaters have been replaced with more consistent air heaters. This leap forward marks a promising new chapter for compressed air technology. You might wonder how the initial cylinder movement is performed, since there would be virtually no energy before the engine starts running. That's simple. These engines are connected to a small electric motor that turns them on and performs a similar function to what a starter and alternator do in a regular car. This is more or less how the modern compressed air engine operates. While compressed air technology might seem promising and tempting, these engines are not without their problems. One of the first and probably the biggest problems you'll encounter is efficiency. Even today, these engines remain extremely inefficient in every way possible. A modern vehicle outfitted with a contemporary compressed air engine would only be good for 80 miles of range at best, which is completely unacceptable. This makes regular city commutes seem like a challenge, let alone driving on longer trips. Since these compressed air vehicles will be running on air alone and not as hybrid air versions of regular cars, refilling the tank by braking will take much more than 10 seconds, making this practice quite impractical. While you could argue that due to the abundance of air, refilling won't be a problem, the truth is that it will be. You will have to meticulously plan your trips to ensure you have enough fuel from refill to refill, which is not pleasant. Furthermore, because pressurized air has a low energy density, you shouldn't expect the vehicles that utilize this technology to be very potent, especially compared to electric vehicles or turbocharged gasoline or turbo diesel engines. Additionally, due to the lighter components that they heavily rely on, these engines will also have virtually non-existent torque, making them not very utility-friendly. They will also need to run at high RPMs, which is a huge problem when an engine doesn't run on liquid fuel. Introducing lubricants into the chamber is far more complex than you'd think, resulting in premature wear and considerably shorter lifespans. What's the point of saving a few bucks initially if you end up spending more on increased maintenance? There's also the question of safety. Pressurized air can be extremely dangerous if the tanks are punctured or damaged. This makes such engines and powertrains less safe than regular gasoline or diesel engines. However, this isn't a primary concern, as electric vehicles and LPG-powered cars are also hazardous in such situations. With that in mind, we must remind you that EVs had the same exact problem, and look at them now. They have literally come light years ahead of what they used to be only 10 years ago, with nothing more than continuous development. This is why we still believe that compressed air engines have a place in the future of the automotive industry. There have already been incentives to solve these issues as soon as possible. For starters, the low-potency issue can be addressed by introducing high-pressure air tanks, which increase the energy density of compressed air and allow the car to produce greater power, making it comparable to high-revving gasoline engines. Two other issues are safety and range, and both can be solved with one solution, by creating a more rigid chassis that serves as a reservoir too. Using materials such as carbon would be ideal, as it would allow the car to remain light, improving range while also being more structurally rigid than steel or aluminum. Unfortunately, carbon is extremely expensive for regular cars, which is why manufacturers might have to opt for thermoplastics, a solid and cheaper alternative. What seems to solidify the bright future of compressed air engines is the fact that numerous small and large companies have delved into creating them over the past 2 decades. For example, an Australian company engineered rotary engines powered by compressed air. This engine, known as the diethyl motor, has been featured in various documentaries and has already seen some limited use with boats and burden carriers. It can also be used in cars. Apart from this, Armando Russi patented his own version of the engine back in 1990, and his prototype car managed to cover 60 miles on a single tank. Ironically, this car was practically assembled in a shed, which makes us wonder how good these engines will be once they are widely adopted. So with that in mind, will we see the widespread adoption of compressed air engines? The widespread adoption of compressed air engines is an iffy topic, to say the least. On the one hand, we could see the adoption of such engines as soon as the next couple of years. If they continue to develop as they are now, we could honestly see these engines getting limited automotive use by 2030. Plus, companies all over the world are already searching for alternatives to regular fuel sources and lithium-ion batteries, as they are extremely harmful to the environment. Toyota's hydrogen fuel cell vehicles have been an interesting option. While they weren't as successful as Toyota expected them to be, they remain a notable engineering venture. By that logic, using air as your propellant would be even more beneficial, as it literally doesn't need to be stored, nor does it cost virtually anything, making it one of the best engines one could ask for. Furthermore, the rising interest in revolutionary zero-emission engines exists because whoever manages to bring a power plant to market that is incredibly revolutionary will be able to set a foothold in the automotive world. By establishing this foothold, the company could dominate over others, automatically acquiring the crown for themselves. Imagine the public reaction if we finally got a zero-emissions engine that cost literal pennies to run. Everyone would want it. Well, not exactly everyone. The truth is that oil and now lithium cost quite a lot of money, which brings in significant revenue for many companies and corporations. As a result, switching to a completely renewable and incredibly easy to acquire and produce fuel source like air would be problematic for them, as they would lose the substantial money revenue they're making now. It is no coincidence that oil is also known as black gold, and that countless conflicts have been waged for oil. Despite large companies like Stellantis and GM being open to re-exploring the compressed air engine, only theoretical discussions and talks have emerged. If this wasn't enough proof of external interference in the automotive world, look at the sodium battery. This battery type solves virtually every problem that lithium-ion batteries have, most notably in terms of ecology and price, yet you'll rarely hear about them or their development due to how unprofitable they are for large battery corporations. Unlike lithium-ion batteries, which rely on expensive and environmentally harmful mining processes, sodium batteries use more abundant and affordable materials, making them a much more sustainable and cost-effective alternative. However, since the current battery industry is heavily invested in lithium technology, the push for sodium batteries remains sluggish, suppressed by financial interests rather than technological limitations. Thankfully, some companies are fighting against these large oil and battery corporations in pursuit of cleaner and more efficient alternatives. Toyota, for instance, has made countless attempts at creating hydrogen and ammonia-powered engines, demonstrating their incredible devotion to making the world a better place. Unlike traditional internal combustion engines, these innovative power sources produce zero harmful emissions, paving the way for a cleaner future in transportation. While hydrogen fuel cell technology has faced challenges in infrastructure and adoption, Toyota's unwavering commitment to its development proves that alternative fuels still have a place in the industry. In fact, Toyota's all-new engine has turned the entire automotive industry upside down. It offers zero emissions while also being highly practical, cost-efficient, and suitable for mass production. By focusing on making these technologies more accessible, Toyota is showing that sustainable solutions don't have to come at the cost of convenience or affordability. Unlike electric vehicles that rely on expensive lithium batteries, Toyota's new approach aims to provide an alternative that is both eco-friendly and widely adoptable. Toyota is too big a company to remain silent or be intimidated by oil and battery corporations, which is why this breakthrough in automotive technology might actually see the light of day in the very near future. If a major player like Toyota continues to push the boundaries of sustainable innovation, it could force the entire industry to follow suit. This could mark a turning point where clean energy solutions become mainstream, challenging the dominance of traditional fuel and battery industries and paving the way for a truly sustainable future in transportation.